Welcome. We were looking at the deployment part of data science lifecycle, and we are trying to build a loan eligibility prediction chatbot. As we have discussed so far, this is a classification problem. And so far, we have done exploratory data analysis. Then we have also done data transformation, feature engineering. We have converted categorical variables into numeric variables by either dummification or by label encoding. And finally, we have reached this stage where all the columns are in numeric format. Now, the step which comes is model build, for which we will create X train, X test, Y train, and Y test using train df new. Remember that always model is trained on train dataset. So here test dataset nowhere comes into picture. So from sklearn we import train test split, and first we create X. X is equal to train df new dot drop column loan status. So that means take entire train df new data frame except this one column, drop this one column, because that is the target variable loan status, whether or not loan will be granted. Now y is train df new loan status, that is the target variable alone, while here all variables except the target variables. Okay, so that is what is x and y. Now from that you can again split X train, X test, Y train and Y test. And that is done in this manner. Train test split X, Y test size is suppose 30%. You can keep 20% or anything. Random state, any number you can take. Okay. So then let us create this four subsets. Created. Now import random forest classifier from sklearn.ensemble. This random forest is actually like multiple decision trees, and collection of such multiple decision trees or multiple other models also, they are that is called ensemble. So this is sklearn ensemble, and from that we are importing random forest. And then the random forest classifier n estimator is 100, so that is the number of estimators which we want to take, and the maximum depth is 10. If you keep too much maximum depth, then some kind of overfitting etc may occur, particularly for a single decision tree. For random forest, that overfitting issue is not much. Classifier is immediately created. Now the training starts, and even that training also is not taking much time because our data set is small. So this is now fitted model, and we will use this fitted model to predict on test data set. Okay, test data set is also obtained from train df new only, but that is this X test. And we will try to predict the values of Y test, and those predicted values of Y test will be compared with actual values of Y test. So then we will get how accurate our model is. So fitted model is obtained. Now we are predicting the values. We have got some predictions, and now we import certain metrics which are used to measure the goodness of our model. So sklearn.metrics, from that import this accuracy score, confusion matrix, and classification report, and then display. So at present we are getting around 79% accuracy, which is again not exceptional, but around 80% accuracy by an automated chatbot will be good, because some people may argue that human managers with a very high level of diligence can I mean disburse the loans with much higher accuracy. But there are certain other issues. For example, one is they will take a lot of time to do this due diligence, and second thing is human managers may have very high level of skill set, but what about the integrity? So it is better to first do automated filtering of applicants by a reasonably good model. And remember, we have not yet tried many of the things. For example, we did imputation by mean and mode, but ideally median should have been used, or much more advanced imputation techniques should have been used. Then we can even get higher accuracy. Okay. So then display the confusion matrix also. So this is the confusion matrix, and those who are familiar, they know that it gives that true positive and true negative and false positive and false negative, etc. And we want to use the report. We have here imported classification report from sklearn.matrix. So this is the report ultimately which is printed. So precision is pretty good. Recall of the model is not that good for zero, that is for non-loan granting situation. Precision is good for one, that is when loan is granted, and recall is also good for one. So that is good enough. Now accuracy, you can see that in both it is the same. F1 score is also reasonable, 0.85 for classification of one. Support is also good enough. So then let us see how many features are there, because this model still is high complicated model because there were large number of features. So if you see, these are the number of columns in X train. So we are trying that if we can eliminate a few feature and still get a model with a reasonable accuracy, because here what happens is that this accuracy may look higher, around 80%. But the problem with such model is that when they are tried on unknown data, completely unknown data, they may not perform well. While a simpler model with few features, so out of these columns, we are trying to see which are the most important column. Then a simpler model with few features that often performs well on unknown data set. So let us try to see which features should be kept. Okay. So here you can see that we are using this select from model feature from sklearn.feature selection, and we are finding that support for the selection. So wherever this true is there, those metrics are important. So then that means basically only four metrics are important. Now, what are that four? Then settle. Now this, and you can see that these are the four features. Okay. This reducing the feature reduces the overfitting chance and it improves the generalizability. Of course, it may reduce the accuracy slightly. So it is always a trade-off. But if accuracy does not decrease much, then you must go for simplest possible model. Now let us take X train and Y train with that only reduced number of features. Okay. And let us display the confusion matrix using this function def run random forest. And this time, in fact, I am getting almost the same or better accuracy. And this is the confusion matrix. Then using just that many features, I am trying to fit a random forest classifier. RFC means random forest classifier. And then I am predicting using that simplified model. So this is that simplified model, and accuracy is still nearly the same. And then I get X train. What is my X train? So that I can find one particular observation, say this observation, just to check how good my prediction is. So for this observation, if you see 337th observation, then these are the values of four variables: 2500 applicant income, 4600 co-applicant income, 176,000 loan amount, and 360 loan amount term. And I think loan amount term we have eliminated. So then credit history 1. And then we want to decide what was the verdict, that is whether loan was granted or not. Remember, this is train set. So yes, loan was granted. So now let us predict by giving those four features, and let us see what answer is obtained, whether we get the same answer or not. This is already an observation in which the loan status is already known, but we are checking our models. And let us use prediction, and you can see that whatever was the value of prediction status loan was granted, same is predicted by our reduced feature or simplified model. Now we want to make this model ready for deployment. That process is called pickling, or in scientific term, it is called serialization. Now, for pickling, there are multiple ways. So I'm showing all ways, and I'm saving the models as loan model 1 dot pickle, then second method loan model 2 dot save, and third method loan model 3 dot save. Just for differentiating, because I have already saved loan model dot pickle. So this, and this. And if I show you, they will be here. Yes, loan model 1 dot pickle, loan model 2 dot save, and loan model 3 dot save. And here was loan model dot pickle when I was doing first a trial run of what my this Jupyter notebook is performing. So you can serialize the model by any one of the three methods. Both are all are fine. Usually this method is preferred for small size model and small data set, while this method with protocol is equal to 2 is used for large data set. Okay. Now what we will do next is this pickled model we will take in a PyCharm or that type of IDE, because this Jupyter notebook is great for understanding and for EDA and feature engineering and everything. It can even generate a full serialized model easily. But for serving that model to the end user, you have to develop some user interface. So that is why we will develop one this kind of project, and in that project this will be that loan model dot pickle, and we will create a Flask app like this, and we will create this kind of user interface. And if I run this, then I can enter those values,